Right. So, welcome back, everyone. Today we're diving into something that's super important for anyone who wants to become, an AWS certified solutions architect associate.
Yeah.
And that is practice questions. We've got a whole bunch of them, and we're not just going to give you the answers. We're going to really break down the WHY behind each answer.
Yeah, like how they connect to that bigger picture of AWS architecture.
Well, exactly.
So what I find really fascinating about these questions is how they force you to think like a solutions architect.
Yeah.
Like you start to see how the different services can all work together, to create these really elegant solutions.
Right.
And then also how, those seemingly small details can make a really big difference.
Yeah.
In terms of cost, performance, or security.
Okay, cool. So let's jump right into the first one here.
Okay.
So question 401 kind of throws us right into the deep end with a pretty common scenario. Yeah. Imagine we've got a company, they've got their own, on-premise data center, but they want to start using AWS for some serious data analysis.
That's great.
Right? Mm-hmm. Their applications are all running happily on their own servers.
Yeah.
But they want to tap into, all that power that the cloud offers, but without causing a major disruption. So what's that bridge that lets them have the best of both worlds?
Well, in this scenario, the key really is smooth integration.
Right.
Without any hiccups.
Yeah.
So the answer here is AWS Storage Gateway.
Okay.
Think of it like a secure data pipeline between those on-premise servers and the AWS cloud. So their apps can keep running, as is, but now they have the ability to, use all of those AWS services for those data-heavy tasks.
Right. So it's like dipping their toes in the cloud.
Exactly.
Without diving right in.
Yeah.
Okay, cool. Question 402 ramps up the complexity a bit. This time, we've got a company with 3 different VPCs, one for development, one for testing, and of course, one for production. And all 3 need to talk to each other and back to their data center. So the challenge is, how do you design this network where everything's, securely separated but can still communicate efficiently?
So this question brings up the idea of network segmentation in AWS.
Right.
And it's a really important one. The best way to achieve this, I think, is using a hub-and-spoke model with VPC peering.
Okay.
So in this case, the production VPC acts as the central hub.
Okay.
And then those development and testing VPCs connect to it.
Got it.
Through peering connections.
Right.
And then we establish that direct connection from the production VPC back to their data center.
Okay.
And this way you prevent any accidental mixing of resources, between those different environments.
Right. It's like having, dedicated lanes on a highway.
Yeah.
And they only merge when absolutely necessary.
I like that analogy.
Right. Okay, so question 403 shifts gears a little bit.
Okay.
And takes us into the world of containers.
Yeah.
So we've got a company that wants to move their containerized application to AWS.
Okay.
And it's currently running on a Kubernetes cluster and using MongoDB. But here's the catch. They can't make any changes to the code or how it's deployed.
Oh, wow.
Right. So what's that AWS service that makes this lift and shift migration possible?
So this is where Amazon EKS really shines.
Okay.
It's that managed Kubernetes service that AWS provides. So it provides that, very familiar environment for those containerized applications.
Right.
And they can move their app with minimal changes, if any at all. And then to handle that MongoDB data, we bring in Amazon Document DB with MongoDB compatibility.
Okay.
So it gives them all that functionality of Mongo, but with, all of the benefits of AWS management.
Got it. So it's like moving into a new apartment that's already furnished and decorated, to your liking.
Exactly.
Right. So question 404 brings us back to the world of databases.
Okay.
We have a company, and they've already moved their application to AWS, and they're using Amazon RDS for Oracle as their database.
Okay.
But they're running into these performance bottlenecks, and storage costs are starting to become a concern.
What's the AWS solution that can help them optimize both the performance and the cost?
I think in this case, we need to think about a change in the database technology itself.
Okay.
So migrating to Amazon DynamoDB, a NoSQL database, can be, a complete game changer.
Okay.
Because DynamoDB is designed for that high performance and scalability that, you need in situations where traditional relational databases might struggle.
Right.
And it can handle those, large binary objects, those BLOBs that often bog down relational databases. Plus, DynamoDB's pay-as-you-go pricing model can really help control those, rising costs.
Gotcha. So it's kind of like swapping out a clunky old engine.
Yeah.
For a sleek high-performance model.
Exactly.
You get the speed boost and you save on fuel.
Exactly.
Question 405 now. This one throws security into the mix. So we've got a company that wants to keep its, back-end systems hidden away from the internet.
But they need to make their web portal accessible to the public. So what's that AWS service that lets them balance security and accessibility?
This is like a classic web application architecture problem.
Yeah.
The solution here is to use an application load balancer, ALB, in their public subnets.
Okay.
That ALB acts as the gatekeeper, handling all of that incoming traffic from the internet. It offloads that SSL termination from the EC2 instances and then routes that traffic to those instances running in the more secure private subnets.
Okay.
This way, the backend systems are totally shielded from any direct exposure.
So like a secure entryway for a building.
Exactly.
Right. Only those authorized visitors can get in.
Yeah.
All right, on to question 406. Here we have a company already using Amazon Redshift for data analytics. They've just acquired a ton of new customer data, like a massive amount.
Wow.
And they need to merge this data with their existing data in Redshift.
Yeah.
And of course, visualize the results. And naturally, they want to do all of this without spending a fortune or weeks on data migration. So what's that AWS service that can pull off this seamless integration?
This is a great example of how AWS services can work together.
Yeah.
So the hero here is Amazon Redshift Spectrum.
Okay.
It's super cool. Like, it lets you directly query data in S3 without having to load it into Redshift first.
Right.
So that means they can do, really in-depth analyses without that time-consuming and costly data movement. And then for visualization, Amazon QuickSight comes in as this powerful tool that allows them to create those interactive dashboards and reports.
Got it. So it's like you've got this super efficient research team that can go through a mountain of data and give you those beautifully organized results in a flash.
Exactly.
Okay. Question 407 brings up compliance and data retention.
Okay.
So we have a company that needs to store data in Amazon S3, but they've got some pretty strict rules. Like every change made to an object has to be tracked. And any file over 5 years old needs to be archived for auditing purposes.
Wow.
Right. So how do we make sure they stay compliant while also being smart about costs?
This is a perfect use case for S3 object versioning and lifecycle policies.
Okay.
So object versioning is like having, that super detailed change log. It tracks everything, every modification made to an object. So not only does it help with compliance, but it also protects against, those accidental deletions
Right.
or overwrites.
Yeah.
Then you can use a lifecycle policy to automatically move those older files to S3 Glacier Deep Archive,
Okay.
which keeps the data accessible for auditing,
Yeah.
but at a much lower cost.
So it's like having a self-organizing archive.
Exactly.
Right, that automatically moves those dusty old boxes to like a cheaper storage unit,
Yeah.
but keeps like a perfect inventory of everything.
Exactly.
Right. Okay, so question 408 takes us into the world of like viral videos.
Okay.
So we've got a media company, and they're storing all their video content on an Amazon EBS volume.
Okay.
But one of their videos has suddenly become this global sensation. Right. And their costs are like skyrocketing.
Oh.
So what's the AWS solution that can handle this crazy surge in demand
Right.
while keeping those costs in check?
This is where we need a content delivery solution that can scale and is cost effective. So the answer is to move those videos to Amazon S3 and then distribute them globally using Amazon CloudFront.
Okay.
S3 is a great choice for large media files because it scales so well. And CloudFront comes in as that, delivery expert, sending out the content through that network of edge locations around the world. It reduces latency for viewers and helps control costs.
Gotcha. It's like having this global network of video vending machines.
Exactly.
Right. Instant delivery of that viral content no matter where they are. Now, question 409 kind of takes us from viral videos to like fluctuating workloads. We've got an application where users are uploading, small files to S3.
Okay.
Each file needs a bit of processing to transform that data and save it in JSON format. But the demand, ebbs and flows unpredictably.
Right.
So what's that flexible AWS solution that can really adapt to that kind of unpredictability?
This sounds like a job for a serverless approach.
Okay.
So the solution is to configure Amazon EMR
Okay.
to read those uploaded files from S3 and process them, as they come in.
Okay.
EMR provides that managed Hadoop framework, which is great for processing large data sets. It can handle that changing demand really well.
Right.
And then they can configure EMR to run a script that takes that data and transforms it to JSON and then stores those results
Right.
in an Amazon Aurora DB cluster for analysis.
So it's like a data processing pipeline that automatically adjusts its speed
Exactly.
based on, the flow of incoming files.
Mhm.
Okay, so question 410 brings together security and, developer freedom.
Okay.
A solutions architect wants to give individual developers their own AWS accounts through AWS organizations, which is great for isolation, but they need to keep those security controls, really tight, especially because those developers will have root user access to their accounts. So how do we strike that balance?
This is where service control policies, SCPs, really come into their own. So
Right.
they need to create an SCP
Right.
that says, absolutely no modifications to CloudTrail configurations.
Okay.
And that ensures that API calls are logged in every account.
Okay.
So even with that root user access,
Yeah.
they can't tamper with those logs.
Gotcha. So it's like having that security camera that's always on no matter what.
Exactly.
Okay. Question 411. So we're talking about performance optimization here. We've got an application running on EC2 instances across multiple availability zones,
Okay.
all neatly tucked behind an application load balancer.
Right.
And it's running nice and smooth when those EC2 instances are at around 40% CPU utilization.
Okay.
So how do we maintain this sweet spot even as traffic goes up and down?
So in this case, I think we should use a target tracking scaling policy for the auto scaling group.
Okay.
So this policy basically automatically adjusts the number of EC2 instances
Right.
based on that target CPU utilization that you set.
Okay.
So as load increases, it spins up more instances to keep the performance at that level. And then
Yeah.
if things calm down,
Yeah.
it scales back down.
Right. Super efficient. So question 412 presents us with a company that's juggling multiple websites,
Right.
each with its own unique traffic patterns and needs.
Right.
They're looking for a solution that can adapt to that dynamic demand
Right.
while being mindful of the costs.
Mhm.
So what's the AWS approach that combines scalability and cost effectiveness in this situation?
So the key is to use the right tool for the right job.
Yeah.
So I recommend using EC2 auto scaling groups for those dynamic elements of their sites.
Okay.
But for that static content, like images and scripts,
Yeah.
S3 website hosting can be a really cost-effective solution.
Okay.
So S3 provides all of that scalability
Yeah.
and durability for those static assets.
Okay.
So it can keep those costs really low.
Makes sense. So question 413 kind of takes us back to that data transfer and backup realm.
Okay.
And we've got a company that needs to back up small amounts of data from their on-premise NFS servers to Amazon S3, and they want to do it regularly.
Okay.
So they're looking for a solution that's simple, cost-effective,
Right.
and doesn't need them to manage like a bunch of infrastructure.
Yeah.
What fits the bill here?
The answer is to use AWS Transfer for SFTP.
Okay.
It's a managed service
Yeah.
that lets them do secure file transfers using that, SFTP protocol,
Right.
which a lot of companies already use.
Yeah.
So they can change their scripts
Yeah.
to point to the AWS transfer for SFTP server, and the service handles everything else,
Okay.
moving those files to S3.
Gotcha. So AWS Transfer for SFTP, it's like having that reliable and secure courier service,
Exactly.
right, that picks up those data packages,
Yeah.
delivers them to that S3 vault.
Exactly.
Right. Question 414 puts high availability front and center. So imagine you have a company that wants to host their web application in a VPC,
Right.
and it needs to talk to a database within that same VPC.
Okay.
They absolutely need a solution that can handle failures gracefully
Right.
and keep their application up and running. So what's that architecture that provides this kind of resilience?
This question emphasizes that, you have to design for failure in AWS.
Right.
So the answer is to combine load balancing and multi-AZ deployments.
Okay.
They should deploy a load balancer in that multi-AZ configuration
Okay.
with an auto-scaling group of web servers behind it.
Yeah.
Then they deploy RDS
Right.
in a multi-AZ deployment for their database tier.
Okay.
So even if one availability zone has problems, the application's still accessible.
Right.
And that database keeps running.
So it's like having that backup system ready to go if the main one
Yeah.
falters. Question 415 is similar, but this time they want high availability within just one region. So how do we ensure their application stays up even if there's a problem within that specific region?
In this case, they need to spread those resources across multiple availability zones within that region.
Right.
So they deploy those EC2 instances for their application
Right.
across at least 2 AZs.
Got it.
And just like before, that RDS-DB instance is in a multi-AZ deployment. Hmm. This ensures that even if one AV, has trouble,
Yeah.
the application stays online and
Right.
the database keeps running smoothly.
Just like having those backup generators that kick in, if the power goes out in one part of your house.
Exactly.
Speaking of optimizing resources, question core 16 brings up cost management.
Okay.
A company's using S3 for storage, but they've got thousands of buckets, and their lifecycle policies are like all over the place.
Mm.
It's costing them a lot of money.
Oh.
So what's that AWS service that can help them control costs without sacrificing data availability?
So S3 intelligent tiering is like having a storage optimization expert, working 24/7. It automatically moves data between tiers based on how it's being accessed.
Mhm.
So that frequently accessed data stays in the fast lane,
Yeah.
while that less used data
Right.
is moved to a slower, cheaper lane.
Got it. So it's like a self-organizing closet.
Yeah.
Question 417 takes us into cost tracking.
Okay.
So a company's application is making calls to a third-party service, and they're charged based on the number of calls. Their finance department needs to track those calls to make sure they're not overpaying.
Hmm.
So how can AWS help them keep those tabs on those service calls?
This highlights why detailed monitoring is so important in AWS.
Right.
So the solution is to publish a custom CloudWatch metric that specifically counts those calls
Okay.
to that third-party service.
Got it.
So CloudWatch is super powerful for monitoring,
Yeah.
and it lets you track different things about your AWS resources. So by creating a custom metric,
Right.
finance gets clear visibility into their service calls.
Okay, so CloudWatch custom metrics, they're like having that, meticulous accountant who tracks every penny spent, right, on those service calls.
Yeah.
All right, question 418. We're back in the data transfer world.
Okay.
A company needs to copy files from their on-premise application to AWS.
Okay.
They have a VPN connection, but the dev team can't make code changes right now.
Right.
What AWS service provides that simple solution for copying those files to the cloud?
So in this case, I would recommend using Amazon FSx for Windows File Server.
Okay.
It bridges those two environments
Okay.
so they can modify their existing scripts to copy those files to the FSx file system, and FSx takes care of replicating everything to AWS.
So it's like a magic portal that moves those files over without disrupting the application. Question 419 focuses on those pesky performance bottlenecks. We have an ASP.NET MVC application
Okay.
running on a single EC2 instance. They're seeing slow response times during peak hours.
Mm-hmm.
They need a solution that can handle that increased traffic without any complex configurations.
So this is where AWS Elastic Beanstalk comes in.
Okay.
It makes it really easy to deploy and manage web applications
Right.
because it handles so much of the underlying infrastructure.
Okay.
They can deploy their app to Elastic Beanstalk
Yeah.
and configure it to scale based on load and time. So it scales up during those busy times and then back down when traffic is lighter.
Got it. So it's an auto-scaling genie
Exactly.
that grants those performance wishes. All right, last one for this round. Question 420. This one brings up data security. A company has a bunch of static images for their website stored in an S3 bucket.
Okay.
They've already locked down access, only privileged users can get in.
Right.
But they want to add like extra layers of protection, just in case.
Right.
Right, so what extra steps should they take?
So this is where we're talking about that layered security approach.
Yeah.
So first, they should enable versioning on that bucket.
Okay.
It's like having a time machine for your data.
Right.
It keeps a history of every version of an object.
Right.
So if someone accidentally deletes a file or makes a mistake,
Oh.
they can easily go back to a previous version.
Right.
And then they should enable MFA delete,
Okay.
which requires multi-factor authentication before anyone can delete anything.
Right.
So it's like having, that second lock on the vault.
Gotcha. So S3 versioning and MFA delete.
Right.
It's like having, that fortress around your data,
Exactly.
keeping those images safe and sound.
Exactly.
Okay, so that wraps up our first set of questions, but we've got plenty more to explore.
We do.
Stay tuned as we continue our deep dive
Yeah.
into these AWS solutions, architect associate, practice questions, and uncover, even more insights into the world of cloud architecture.
All right, we'll be right back. All right, let's jump back into these practice questions. Question 421 talks about a company that has a build server with multiple Linux instances running in an auto-scaling group. They need a way to provide storage that's consistent, can be mounted and used for their jobs and configurations, regardless of how many instances are actually running.
So they need a storage solution that's flexible and can grow and shrink along with their auto-scaling group.
Exactly. And it's got to be accessible from all those Linux instances. So what do you think would work best here?
Well, it sounds like they need something that can scale easily and be shared across all those instances.
Right. The solution here is Amazon Elastic File System, Amazon EFS. It gives them a managed Elastic NFS file system that can be mounted on multiple EC2 instances at the same time. It scales automatically as their storage needs change, so they don't have to worry about provisioning and managing capacity. Plus, it integrates seamlessly with auto-scaling, so new instances can just automatically mount the EFS file system and access the data.
It's like a giant shared drive that all the build server instances can use no matter how many there are. Okay, let's look at question 422, which is about shared storage for Windows-based workloads.
Okay.
So we've got a company with .NET application servers and a Microsoft SQL Server database, all running on Windows Server 2016 EC2 instances.
Got it.
They need a shared file system that works with Active Directory, is highly durable, and is managed by AWS. It also needs to provide high performance to keep those applications running smoothly.
It sounds like they need a solution that's specifically designed for Windows environments in AWS.
Exactly. What would you suggest?
In this case, I'd recommend Amazon FSx for Windows File Server. It's a fully managed Windows file system, so they don't have to deal with the complexities of managing it themselves. It integrates with Active Directory, provides high durability with data replication, and delivers the performance needed for those applications.
Amazon FSx for Windows File Server, it's like having a high-end file server delivered right to their AWS environment.
Exactly, pre-configured and ready to go.
Okay, let's move on to question 423, which is about optimizing storage performance. We've got an application running on EC2 instances that generates temporary transactional data, and they need a storage solution with consistent IOPS that they can configure.
So performance is critical here, and they need a storage option that gives them control over those IOPS levels.
Exactly. What's the best way to handle this?
I think the best approach is to use a combination of storage solutions. They should use a general-purpose SSD, GP2 root volume for the OS and applications, but for that transactional data, they should use a separate IOPS SSD IO1 data volume. That way, they can configure the exact IOPS performance they need for those critical transactions.
It's about choosing the right storage type for each specific need.
Exactly.
Like having different tools in your toolbox, you use the right tool for the job. Question 424 brings us into the world of mobile gaming. A game company is having performance problems with their metadata stored in an RDS-DB instance. Just scaling the database isn't cutting it. They need something that can handle rapid updates and retrievals, offers snapshots and replication, and provides those super fast response times that gamers demand.
This sounds like a perfect use case for Amazon DynamoDB.
Okay, tell me more.
It's a NoSQL database designed for high-volume, low-latency workloads like managing metadata in games. It can handle the rapid updates and retrievals they need, offer snapshots and replication for data protection, and provides those sub-millisecond response times essential for a smooth gaming experience. Plus, with DynamoDB global tables, they get multi-region replication, ensuring low latency for players worldwide and high availability if one region goes down.
So it's like having a network of game servers that can respond instantly to players no matter where they are.
Exactly. Global reach and high performance.
All right. Question 425 is about expanding an application across multiple regions. A company has an EKS cluster running microservices. They're using S3 for object storage, DynamoDB for metadata, and they want to make this whole setup work across multiple regions for better availability and performance. What are the steps to create this kind of multi-region architecture?
This one's about thinking globally. It's not just about replicating infrastructure, but ensuring it all works together seamlessly across different regions. First, they should use API Gateway to create a global endpoint for their EKS cluster, providing a single point of access for clients no matter the region. Then they deploy an EKS cluster and an S3 bucket in another region and set up cross-region replication for those S3 buckets. Finally, they need to enable global tables for DynamoDB, replicating those tables across regions.
It's like creating a mirror image of their infrastructure in another region so their application and data are always available no matter what.
Precisely.
Question 426 dives into high-performance computing, HPC. A solutions architect is designing a system for an HPC workload that involves hundreds of EC2 instances. They all need to access a shared file system simultaneously for processing large data sets. It also needs to have low latency and easy access for post-processing. What AWS service can handle those demanding HPC requirements?
For this, they need a file system that's built for speed and can handle parallel access from all those instances.
Right, something that's specifically designed for HPC workloads.
Exactly. The solution is to use Amazon FSx for Lustre. Lustre is a file system made for HPC, providing that parallel access, low latency, and high throughput they need for those intensive tasks. They can also link that FSX for Lustre file system to an S3 bucket for easy access and analysis during post-processing.
It's like building a superhighway for data, so those EC2 instances can process information at lightning speed.
I like that analogy.
Question 427 is about controlling access to content based on location. A company serves content globally, but they need to block access from specific countries because of legal reasons or copyright restrictions. How can they set up these location-based access controls?
In this case, they can use Amazon CloudFront.
Okay. How does CloudFront help with that?
CloudFront is a global CDN, so it not only makes content delivery faster, but can also be configured to restrict access based on location. They can set up rules in CloudFront to block access from specific countries, making sure they comply with regulations while still delivering content to the rest of the world.
So it's like having a digital bouncer at the door, checking IDs to make sure only people from allowed regions can enter.
That's a good way to put it.
All right, question 428 is about managing and organizing resources. A company has multiple applications running across different regions, and all their resources are tagged with an application tag. Their solutions architect needs a way to quickly find all the components associated with a specific application.
They need a tool that can sift through all those resources and quickly pinpoint the ones related to a particular application.
Exactly. What's the most efficient way to do that?
The solution is to use the AWS Resource Groups tag editor. It lets you search and group resources based on their tags so you can quickly locate everything associated with the specific application value.
It's like having a search engine for their AWS resources,
Yeah,
making it easy to find what they need in that vast cloud environment.
precisely. Organization is key.
Question 429 is about designing a storage system that prioritizes scalability, availability, and durability.
Okay, sounds like a mission-critical system.
Right. They need to store client case files, which are essential company assets. These files need to be accessed by multiple application servers running on EC2 instances, and the storage system needs to be able to handle growth and have redundancy to prevent data loss.
They need a storage system that can keep up with their business and keep their data safe. Amazon Elastic File System, Amazon EFS, is a good fit here. It allows them to create that network file system that multiple EC2 instances can access. EFS scales automatically, ensuring they always have enough storage, and it offers high availability and durability through replication across multiple availability zones. Plus, it's a simple pay-as-you-go model, so they're only paying for what they use.
It's like having a secure, ever-expanding file cabinet that the whole team can use, with built-in safeguards to protect those important client files.
A virtual file cabinet in the cloud.
Okay, question 430 is about optimizing network performance. A company has a custom application that performs complex financial calculations running on multiple EC2 instances. They need to minimize latency and maximize throughput between those instances to ensure those calculations are done quickly and efficiently. How can they optimize their network for this high-performance communication?
Network performance can make or break an application, especially for something as time-sensitive as financial calculations. To optimize their network, they should use placement groups.
Placement groups, how do those help?
Placement groups let you cluster instances close together within an availability zone, reducing network latency between them. And for even more consistent performance, they should make sure all the instances in the placement group have the same instance type.
It's like creating a dedicated express lane for their data, ensuring it travels between those instances as quickly as possible.
Exactly. No traffic jams for their data.
Question 431 takes us back to database migration. A company is moving its on-premises application, including its SQL Server database, to AWS. They want high availability for the database and minimal operational overhead, but they can't change database engines because their code relies on SQL Server-specific features. What's the best way to migrate the database and keep it highly available without adding extra management burdens?
This is where a managed database service can really simplify things. They should migrate the database to Amazon RDS for SQL Server in a multi-AZ deployment.
Okay, so RDS takes care of a lot of the database management tasks, and the multi-AZ deployment ensures high availability.
Exactly. RDS handles the setup, operation, and scaling of the database, while the multi-AZ deployment automatically replicates the database to a standby instance in another availability zone. If the primary instance has problems, RDS automatically switches to the standby, keeping the database online.
It's like having a team of database experts constantly monitoring and managing the database, ensuring it's always available and running smoothly.
A virtual DBA team.
Question 432 is about optimizing a globally distributed workload. A company is serving content globally with an application on AWS. They have a UDP-based workload on EC2 instances across multiple regions, and they want to minimize latency for their users and maximize throughput for the application. What's the best AWS architecture for this kind of global performance optimization?
They need a solution that combines regional load balancing with a global content delivery network.
The two-pronged approach.
Right. They should place those EC2 instances behind an application load balancer, ALB, in each region for efficient traffic distribution within each region. Then, they need to create a CloudFront distribution, which acts as a global CDN with an origin that uses Route 53 latency-based routing to direct requests to the closest ALB. This ensures that users connect to the regional endpoint that's closest to them, minimizing latency and providing a fast, responsive experience.
It's like having a network of traffic controllers directing users to the fastest route, ensuring a smooth journey to their destination.
Keeping things flowing efficiently.
Question 433 focuses on security and least privilege. An engineering team is working with Lambda functions and needs to create roles and manage policies in IAM. How can we give them the necessary permissions, but still stick to the principle of least privilege?
This is where fine-grained access control becomes critical.
So limit their access to only what they absolutely need.
Exactly. The best way to do this is to create an IAM role with a managed policy attached that grants only those actions specifically needed for Lambda functions. Then, both the engineering team and the Lambda functions can assume this role. This means the team can manage those functions but can't do anything outside of those defined permissions, and the functions themselves only have the permissions needed for their tasks, minimizing potential security risks.
It's like giving them a key that only unlocks specific doors, keeping everything else secure.
Precisely. Restricting access to prevent any unauthorized entry.
Question 434 brings us back to gaming and high-performance data management. A company is running a multiplayer mobile game that requires live location tracking of players. They're using RDS for PostgreSQL with read replicas, but it's struggling to keep up. They need something that can handle those rapid updates and retrievals of location data, especially during peak times. How can we help them achieve those lightning-fast response times?
This is where caching can really make a difference. They should deploy Amazon DynamoDB Accelerator, DAX, in front of their existing RDS instances.
Okay, so DAX acts as a high-speed cache for their location data.
Exactly. DAX is a fully managed in-memory caching service that can dramatically boost performance for read-heavy workloads on DynamoDB. By modifying their game to use DAX for those location operations, they can get those sub-millisecond response times they need for a smooth and responsive gaming experience.
It's like giving their database a turbo boost.
Exactly, eliminating those lag issues that can ruin a gaming session.
All right, let's look at question 435, which is about optimizing database migrations. A company is moving a large mission-critical database to AWS using RDS for MySQL with provisioned IOPS. They're using AWS Database Migration Service, DMS, but it's taking longer than expected. Network bandwidth isn't the issue. What can they do to speed up the migration?
Sometimes it's about fine-tuning the process itself. There are a couple of things they can try. First, they can temporarily disable logging on the target RDS instance until the initial data load is complete. Logging adds overhead during migration, so turning it off temporarily can speed things up.
Okay, so reduce the workload on the database during migration.
Right. Second, they can restart the DMS task on a new DMS instance with transfer acceleration enabled. Even if the network isn't the bottleneck, transfer acceleration can still boost performance, especially for long-distance transfers.
So it's a combination of tweaking database settings and leveraging network optimization techniques. Question 436 is about managing access across multiple AWS accounts. A company has separate accounts for each department and needs a way to share an S3 bucket with all of them. They're looking for a simple solution that doesn't involve complex IAM configurations in each department's account.
They need a way to grant access to that bucket without making changes to individual accounts.
Right, something straightforward. What's the easiest way to do that?
They can set an S3 bucket policy that explicitly allows cross-account access to those other departments.
Okay, so a bucket policy defines who can access the bucket, regardless of their account.
Exactly. By granting permissions to the other department's AWS account IDs, they can access the shared bucket without needing to make any changes to their own IAM configurations.
It's like creating a guest list for the S3 bucket, controlling who's allowed entry. Question 437 deals with resilient task scheduling. There's a data processing job that runs once a day and can take up to 2 hours. If it's interrupted, it has to restart from the beginning. How can they address this in a cost-effective way and ensure the job completes even if there are problems?
They need a solution that ensures the job completes even if there are interruptions, and it needs to be cost-effective since it's only running once a day.
Right, reliability is key, but we don't want to overspend.
The best approach is to use Amazon ECS tasks running in Amazon EC2, triggered by Amazon EventBridge scheduled events. They can schedule a daily event in EventBridge that triggers an ECS task to run the job. ECS tasks can restart automatically if interrupted, and using EC2 for those tasks can be a cost-effective solution for infrequent jobs.
So it's like setting a reliable alarm clock that ensures the job starts on time and finishes, even if it has to hit the snooze button a few times.
Exactly. Automated and resilient.
Question 438 is about optimizing performance for a multi-region application. A company has an application deployed in 3 AWS regions, using ALBs in each region. They want to use Route 53 to distribute traffic between regions based on which one offers the best performance. What Route 53 configuration can achieve this intelligent traffic routing?
This sounds like a great use case for geolocation routing in Route 53.
Okay, so Route 53 can direct traffic based on where the user is located.
Right. They should create a Route 53 geolocation routing policy that maps users to the closest region. This ensures users are directed to the region with the lowest latency, providing the best possible experience.
It's like having a global network of traffic directors guiding users to the fastest route, ensuring a smooth and speedy journey to their destination.
Keeping those data packets flowing smoothly.
Question 439 is about shifting from batch processing to near real-time data analysis. A company is analyzing clickstream data from multiple websites using batch processing on Amazon Redshift. They want to move towards near real-time processing for faster insights, but need a cost-effective solution that's easy to implement and doesn't require complex infrastructure.
This is a perfect opportunity to embrace serverless architecture and real-time data streaming.
So get those insights flowing more quickly. What services would you recommend?
They can combine AWS Lambda and Amazon Kinesis Data Firehose. Kinesis Data Firehose can capture and stream that clickstream data and trigger a Lambda function to process it in near real time. Lambda is serverless, so no infrastructure management is needed.
It's like having a high-speed conveyor belt delivering data to a team of expert analysts working in real time.
Exactly. Instant insights from that data stream.
All right. Question 440 is about optimizing storage costs for data with different retention requirements. A company processes data daily and stores it in S3. They need to analyze it daily for a week and then keep it accessible for occasional analysis but not readily available. They want to find the most cost-effective storage option for this.
This is where S3's lifecycle policies can help manage data retention and costs.
So move that data around based on how it's being used.
Right. The best approach is to set up an S3 lifecycle policy to transition objects to Amazon S3 One Zone Infrequent Access, S3 One Zone IA, after 30 days. S3 One Zone IA is a lower-cost storage class perfect for data that's accessed less often. This way, they reduce costs while still having access to the data for those occasional analyses.
It's like having a self-storage unit that automatically moves those boxes you rarely use to a cheaper storage tier.
A great analogy, keeping things organized and cost-effective.
Question 441 is about secure file sharing. A company needs to deliver files from S3 to people who don't have AWS credentials. They also need to give them time-limited access to those files, so access is revoked after a specific time. They need a way to share those files securely without giving permanent access to their AWS environment. Right, so temporary secure access.
Exactly. The answer is to generate pre-signed URLs. These URLs provide temporary access to S3 objects, allowing users to download or upload files without needing AWS credentials. They can even set expiration times for those URLs, so access is automatically revoked after a specific period.
It's like giving someone a temporary pass to access a secure area. They have access for a limited time, and then it's revoked.
Secure and controlled access.
Okay, question 442 is about strong password policies in AWS. A solutions architect wants to make sure all new IAM users have to create passwords that meet specific complexity requirements and that those passwords are changed regularly.
So organization-wide password security.
Exactly. How can they enforce these policies across the board?
The most efficient way is to set a password policy for the entire AWS account.
Okay, so a single policy applies to everyone.
Right. Account-level password policies let them set complexity requirements, minimum length, and rotation periods for all IAM users in the account. This ensures consistent security practices without having to configure individual user settings.
It's like having a security guard at the entrance, checking everyone's credentials to make sure they meet the standard.
Exactly. No weak passwords allowed.
Question 443 is about network configuration and high availability. An application is running on EC2 instances in private subnets across 3 availability zones in US East 1. The instances need both internal and internet access to download files, and the company needs high availability for that internet connectivity.
They need to ensure that those instances can always reach the internet, even if one AZ experiences problems.
Exactly. What's the best way to achieve that?
They should deploy a NAT gateway in a public subnet of each AZ.
Okay, so a NAT gateway in each AZ provides redundancy for internet access.
Right. NAT gateways allow instances in private subnets to connect to the internet without having public IP addresses, improving security. By having a NAT gateway in each AZ, they create that redundancy, so even if one AZ has issues, internet connectivity remains available.
It's like having multiple exits from a building, so even if one is blocked, people can still get out safely.
Exactly. Always having a backup route.
Okay, question 444 is about real-time data updates for an online game. A company developed a new web-based video game with a 3D architecture running in a VPC. They're using RDS for my school, and they need a way to show a top 10 scoreboard in near real time. They also want players to be able to pause and resume games without losing their scores.
This combines the need for fast read operations with the requirement for data consistency. How do we make sure the scoreboard stays updated while ensuring player data is saved reliably?
It's about finding the right balance between speed and reliability. What would you recommend?
The solution is to use read replicas for their RDS for MySQL instance. Read replicas are copies of the primary database that can handle read-only queries. By sending those scoreboard queries to a read replica, they take the load off the primary instance and make sure those scoreboard updates appear quickly. This lets the primary instance focus on saving game progress, ensuring that player data is consistently stored.
So it's like having a dedicated team handling the scoreboard updates, letting the main team focus on running the game itself.
Exactly, distributing the workload for better performance and consistency.
All right, question 445 is about secure data access and cost optimization. A solutions architect is building an application that runs on EC2 instances in private subnets across multiple AZs. Those instances need to access large confidential files stored in S3, but they want to minimize data transfer costs.
Moving large amounts of data can get expensive, so minimizing those data transfer costs is essential.
Right. How can they access that S3 data securely without racking up huge bills?
The key is to keep those data transfers within the AWS network. They should create a single NAT gateway in a public subnet and update the route tables for the private subnets to point to that NAT gateway. This allows those EC2 instances in the private subnets to access the S3 bucket without incurring any data transfer costs for traffic between those services.
So it's just like finding a shortcut that avoids those expensive tolls on the data highway.
Exactly. Efficient and cost-effective data movement.
Question 446 is about optimizing S3 storage costs. A company wants to lower their S3 storage costs in production, but can't compromise durability or performance. They need a solution that can identify cost-saving opportunities without manually analyzing each object and its access patterns. What's the first step they should take?
This is where S3's intelligent features come in handy.
So automate that cost optimization.
Precisely. The first step is to analyze their storage usage and identify objects that can be moved to a lower-cost storage class. A great way to do this is to migrate all objects in their S3 buckets to S3 intelligent tiering.
Okay, so intelligent tiering automatically moves data between different storage tiers based on how it's accessed.
Exactly. Frequently accessed data stays in a high-performance tier, and infrequently accessed data is moved to a cheaper tier. This happens automatically, so they don't have to manually manage it.
It's like having a storage consultant who constantly optimizes your storage based on your actual usage. Question 447 is about short-term storage for log processing. A data science team needs storage for nightly log processing. The size and number of logs are unpredictable, and they only need to keep the data for 24 hours. They're looking for the most cost-effective solution without dealing with storage transitions or lifecycle policies.
They need something simple and cost-effective for temporary data.
Exactly.
What would you recommend?
The best option is to use Amazon S3 Standard. It's the standard storage class offering high durability, availability, and performance. It's a great choice for frequently accessed data. Since they only need those logs for 24 hours, S3 Standard makes sense without needing any extra configurations. It's like having a convenient drop-off point for those temporary files. You can store them there, knowing they're safe and accessible, and then clear them out easily when you're done. Question 448 focuses on encrypting a database and its snapshots. A company is running an online transaction processing system on an unencrypted RDS instance with multi-AZ. They're taking daily snapshots, but they've realized they need to encrypt both the database and the snapshots to protect sensitive information.
They need to add that encryption layer without disrupting their existing database.
Right. They don't want to rebuild everything from scratch.
Exactly. The solution involves a two-step process. First, they need to create an encrypted copy of their latest DB snapshot. Even if the original wasn't encrypted, RDS lets you create encrypted copies. Second, they need to replace their existing DB instance by restoring from that new encrypted snapshot. This makes sure the new instance is encrypted, and all new snapshots will also be encrypted, protecting both their live data and the backups.
It's like putting on a new suit of armor for their database and making sure all future copies have that same level of protection. Question 449 is about optimizing storage costs based on different data access patterns. A company stores user data in AWS with a mix of access patterns. Some data is accessed constantly, while other data might go untouched for months. They need storage that can handle both while being cost-effective.
This is where S3 intelligent tiering shines again.
So let S3 handle those different access patterns.
Exactly. Intelligent tiering moves data between different storage tiers based on how it's accessed. Frequently accessed data stays in a high-performance tier, while less frequently accessed data is moved to a cheaper tier. All this happens automatically.
It's like having a self-organizing filing system that keeps the most important files at your fingertips and archives the rest in a more cost-effective way. Okay, question 450 is about performance and cost-effectiveness for an e-commerce site. An e-commerce site has performance issues during flash sales because their DynamoDB database with provisioned throughput can't handle the sudden traffic spikes. They need a way to handle those peaks without overspending during normal times when traffic is lower.
This is a classic scalability challenge. How do we make the database expand and contract as needed?
Right. What's the best way to manage that dynamic workload?
They should switch DynamoDB to on-demand mode during flash sales. On-demand mode lets DynamoDB scale capacity up or down automatically based on the actual traffic, so they don't have to provision capacity beforehand. During normal times, they can switch back to provision throughput mode to manage costs.
It's like having a database with a built-in elasticity, expanding and contracting to accommodate those changing traffic patterns.
A database that can breathe.
Question 451 focuses on database migration with a focus on flexibility and scalability. A company wants to migrate their on-premises MySQL database to AWS, but doesn't want to commit to a specific instance type right away. They expect growth and want a database solution that can scale easily. They also want to minimize downtime during the migration.
They need a database solution that can grow with them and a migration process that's as smooth as possible.
Exactly. What would you suggest?
The best option is Amazon Aurora MySQL. Aurora is a MySQL-compatible database engine known for its performance, scalability, and availability. It handles storage and compute scaling automatically, so they don't have to choose an instance type up front. And the migration can be done with minimal downtime using DMS.
It's like having a database that can expand infinitely to meet their needs without them having to worry about the technical details. Question 452 is about figuring out which IAM role is attached to an EC2 instance. An IAM user wants to know which role is attached to their instance, but only has login access to the instance. They don't have any IAM permissions to view roles or other account-level information.
They need a way to get that information without having broader permissions.
That's right. They only have access to the instance itself.
The answer lies in using EC2 instance metadata. Instance metadata provides information about the instance, including the attached IAM role. The user can run a simple command on the instance to query that metadata service and see which role is being used.
It's like the instance has a built-in information card that reveals its identity. Question 453 takes us back to optimizing performance for that e-commerce website during those flash sales. We've got an e-commerce website experiencing performance issues during those flash sales because their DynamoDB database with provisioned throughput can't keep up with the traffic. They need a solution that can handle those spikes without being too expensive during normal times.
This is where DynamoDB's on-demand capacity mode shines.
Okay, so let DynamoDB adapt to the traffic automatically.
Right. They should switch to on-demand mode during those flash sales. It lets DynamoDB scale capacity based on actual traffic, eliminating the need to provision in advance. Then, they can switch back to provision throughput during normal periods for cost control.
It's like having a database that can breathe. expanding and contracting to handle the changing workload. Question 454 is about data analytics and cost optimization. A company is using Amazon Athena to query sales data stored in an S3 bucket. They also use Amazon QuickSight to visualize that sales data, but want to move away from QuickSight for cost reasons. They need a different way to visualize that data stored in S3 without using QuickSight.
They need a visualization tool that works well with S3 and provides a cost-effective alternative to QuickSight. How about we explore using Amazon Elasticsearch Service and Kibana?
Okay, so replace QuickSight with Elasticsearch and Kibana. How would that work?
Exactly. They can set up an Amazon Elasticsearch Service, Amazon ES cluster. Amazon ES is a managed service offering a powerful engine for search and analytics. It's a great fit for analyzing log data and other types of semi-structured data. They can configure Amazon ES to index the data in their S3 bucket, making it searchable and easy to analyze. Then they can switch to Kibana.
Okay, so Kibana replaces QuickSight,
Yeah.
and it works directly with Elasticsearch.
Right. Kibana is a visualization tool that integrates with Amazon ES. They can use it to create dashboards and reports from that sales data. It makes it easy to explore and visualize the data and uncover those hidden patterns and trends.
So it's like having a dedicated research team that can sift through those sales records and present the findings in a clear, insightful way. Okay, question 455 is about finding the right storage solution. A company is building a web application that'll store a large number of images in S3. They need a storage solution that can keep all those images safe without any risk of data loss. They want to minimize costs, but they also want to make sure that retrieving images is free and that those images are always available when their application needs them. What's the best S3 storage class for this?
It sounds like they need a solution that balances cost effectiveness with high availability and no retrieval fees.
Right, they want to store those images safely and access them easily without breaking the bank.
S3 intelligent tiering is a great fit here.
Okay, intelligent tiering again. Why is it the best choice in this scenario?
It automatically moves those image files between different storage tiers based on how often they're accessed. Frequently accessed images will be stored in those faster, lower latency tiers for quick retrieval, while those less frequently accessed images will be moved to those cheaper tiers, saving them money. And because they want to keep all the images, intelligent tiering makes sure nothing gets lost, even those images that are rarely accessed.
It's like having a smart photo album that automatically keeps your favorites close at hand while storing the rest in a more organized and cost-effective way. Question 456 is about building a media processing workflow. A company building a media sharing application is using S3 for storage. When a media file is uploaded, they need to trigger a multi-step process. That includes creating thumbnails, identifying objects in the media, transcoding videos, and extracting metadata to a DynamoDB table. Traffic for this application can fluctuate a lot, so they need a solution that can handle those changes and is cost-effective.
They need a workflow that can handle all those media processing tasks efficiently and scale up or down as needed. This is where serverless components and orchestration can really shine. They can trigger a Lambda function when an object is added to that S3 bucket. That Lambda function can then start an AWS batch job to handle the media processing steps.
Okay, so Lambda kicks off the process, and then Batch does the heavy lifting.
Exactly. Batch is great for this because it's a managed service that can run batch computing workloads. It provisions the computing resources needed and scales up or down based on the workload.
So it's like having a flexible team of media processors that can handle any size job. And where does the process data end up?
The process data, including the metadata, can be stored in DynamoDB. This makes it easy to search and navigate that media library.
So it's like having an automated assembly line that handles all the transformations and then organizes the results in a searchable database. That makes sense. Okay, question 457 is about replacing an on-premises file server farm. A company is moving to AWS and needs to replace its on-premises Windows file server farm, which uses replication for redundancy. They're looking for something similar in AWS, but with those added benefits of AWS management and scalability.
So they need a managed file storage solution that can replace those traditional file servers.
Right. They want to move away from managing that on-premises infrastructure.
Amazon FSx is a good fit here.
Okay, Amazon FSx. Which flavor of FSx would you recommend?
It depends on their specific needs. They could go with FSx for Windows File Server, which offers features like Active Directory integration and support for the SMB protocol. Or they could choose FSx for Lustre, which is designed for high-performance computing and large-scale data processing.
So it's like having a virtual data center with different types of file servers to handle various workloads. And they don't have to worry about the underlying hardware. Question 458 is about streamlining database management and making improvements to performance, scaling, and durability. A company is currently handling replication and scaling for its MySQL database, running on EC2 instances manually. This is a lot of work, and they want to make things simpler and improve those key aspects of their database.
Sounds like they're ready to move to a managed database service.
Right, they want to offload some of those management tasks and leverage the power of AWS.
I'd suggest migrating that database to Amazon Aurora MySQL and using an EC2 auto-scaling group for their application tier.
Okay, so Aurora takes care of the database, and the auto-scaling group manages the application servers.
Exactly. Aurora handles replication and scaling automatically, so no more manual work there. And the auto-scaling group ensures that the application can scale up or down based on demand.
It's like having a self-tuning orchestra, automatically adjusting to the demands of the performance. Question 459 is about IAM and least privilege. A new deployment engineer needs to use CloudFormation templates to create AWS resources. The solutions architect wants to give them the necessary permissions, but nothing more. How can they achieve this fine-grained access control using IAM?
This is where we layer those security policies to grant just the right level of access. They can create an IAM user for the engineer and add that user to an IAM group. That group should have a policy allowing only CloudFormation actions. That way, the engineer can only work with CloudFormation templates and can't touch other AWS services. To further restrict access, they can create an IAM role with permissions specific to the resources the engineer needs to manage. The engineer can then assume this role when launching CloudFormation stacks, limiting their access to only those specific resources.
It's like having multiple security checkpoints, ensuring that only authorized personnel can access certain areas and perform certain actions. Okay, question 460 is about achieving low latency for database reads while accepting a bit of inconsistency in the data. A company is moving its e-commerce application's SQL database to AWS. They want those common read requests, like product info and customer reviews, to have sub-millisecond response times. To get that speed, they're willing to accept a small amount of stale data in those reads.
This is a common scenario where performance and consistency need to be balanced.
Right. Sometimes you have to make trade-offs.
Exactly. The solution here is to use read replicas. Those read replicas are copies of the primary database instance and can handle those read-only queries. By spreading the read requests across multiple read replicas, they can reduce the load on that main database and get those super fast response times. The slight data staleness is the trade-off they make for that speed.
It's like having a team of super fast researchers who can answer your questions quickly, even if their information isn't perfectly up to the minute. Question 461 is about long-term data archiving and cost optimization. A company wants to store old news footage in AWS. They want to keep costs low since they rarely access these archives, but when they do need to access them, they want to be able to retrieve them within a reasonable time, like within 5 minutes.
They need a solution that's both cost-effective for long-term storage and offers relatively quick retrieval when needed. What storage class fits this scenario best?
Right. It's about finding that balance between cost and accessibility.
Exactly. The best option is to store those video archives in Amazon S3 Glacier and use expedited retrievals when needed. S3 Glacier is a low-cost storage class specifically designed for data archiving. They don't need to access it often. And while standard retrieval from Glacier can take several hours, expedited retrievals give them access to that data within minutes, which meets their requirements.
So it's like having a secure, climate-controlled vault for their valuable archives, with a special express lane for those times when they need to access something quickly. Okay, let's look at question 462. We've got a two-step order processing system. The first step needs to be fast and give the user immediate feedback, while the second step takes longer and will be a separate component. The orders need to be processed in the exact order they're received to make sure everything is accurate.
This scenario requires a messaging service that guarantees both order and exactly one's processing. How can we connect those two components while ensuring those requirements are met?
Right. It's about keeping things organized and making sure nothing gets missed.
We can use Amazon SNS and SQS FIFO queues here. They can create an SNS topic and subscribe an SQS FIFO queue to that topic. After finishing that first synchronous step, the initial component publishes a message to the SNS topic. The SQS FIFO queue, which is subscribed to the topic, gets that message. Those SQS FIFO queues make sure that messages are processed only once and in the order they came in, ensuring those orders are processed accurately. The second component can then process those messages from the queue, doing that longer asynchronous step without impacting the user's experience.
It's like having a dedicated, organized pipeline that delivers those orders to the processing station in the exact sequence they were placed, preventing any mix-ups or delays. Question 463 is about a company gearing up for a big product launch. They're hosting their product information web pages on AWS and are anticipating a huge increase in global traffic. They want to ensure a smooth experience for users worldwide. They currently have EC2 instances behind an ALB in an autoscaling group, a custom DNS name, and HTTPS with a dedicated SSL certificate. This is a good start, but they need to optimize for high availability and performance globally to handle that surge in traffic. They need a way to bring their content closer to those users, improving performance and availability globally. Right. They need to scale up their infrastructure to meet that global demand. Exactly. They should redesign their application to use Amazon CloudFront. Okay, so add CloudFront to their current setup. Why CloudFront?
CloudFront is a global CDN that caches content at edge locations around the world. When a user requests content, CloudFront delivers it from the closest edge location, reducing latency and improving load times. This not only makes for a better user experience, but also helps handle those traffic spikes, preventing their backend servers from getting overloaded.
Amazon CloudFront is like having a network of distribution centers around the world, ensuring those products reach those customers quickly and efficiently, no matter where they are. Question 464 is about database replication for a high-traffic website. A company uses Amazon RDS for MySQL with a primary instance and 5 read replicas for its website. However, the read replicas are lagging behind, especially during peak loads, leading to inconsistent search results. They need to reduce this lag without making big changes to their code or significantly altering their database management practices.
They need to reduce the load on those read replicas to improve performance and consistency.
Right. Speed and accuracy are both important here.
They should deploy Amazon Elasticache for Redis in front of the database and modify the website to check the cache before querying those read replicas.
Okay, so Elasticache acts as a buffer, reducing the number of requests hitting those replicas.
Exactly. Elasticache for Redis is a managed in-memory data store that can be used as a high-performance cache. By caching frequently accessed data in Redis, they lighten the load on those read replicas, minimizing lag and improving consistency.
It's like having a super fast memory bank that stores the most important information so the application can retrieve it instantly. All right, let's move on to question 465, which is about ensuring high availability for a critical application. A company needs at least 4 EC2 instances running their app during normal traffic and needs to scale up to 12 instances during peak times. They can't afford any downtime for this application.
High availability is crucial for mission-critical applications. They need a solution that guarantees a baseline level of availability and can scale to meet peak demand.
Right, always online and ready to handle anything.
Exactly. They should deploy those EC2 instances in an auto-scaling group with a minimum size of 8 instances and a maximum of 12 instances, evenly distributed across 2 availability zones.
Okay, so they always have at least 4 instances running in each AZ, ensuring redundancy.
Right. And during peak loads, the auto-scaling group scales up to a maximum of 12 instances, distributing the additional instances across both AZs to maintain balance and availability.
It's like having a team of athletes who are always ready to take over if one of their teammates gets tired, ensuring the race is always run at full speed. Question 466 is about choosing the right S3 storage class when you're not sure about access patterns. A solutions architect needs to back up application log data to S3, but doesn't know how often those logs will be accessed. The company wants to keep costs low, but needs flexibility in case those access patterns change.
This is where the flexibility of S3 intelligent tiering comes in.
Okay, intelligent tiering again. Why is it a good choice for unpredictable access patterns?
Because it automatically manages the storage tiers for you. It starts by putting those objects in a frequent access tier. If an object isn't accessed for 30 days straight, it gets moved to a cheaper infrequent access tier. And if an object in that infrequent access tier is accessed, it's automatically moved back to the frequent access tier. This dynamic optimization keeps costs down without needing the solutions architect to predict those access patterns ahead of time.
It's like having a storage system that adapts to the changing needs of your data. All right, question 467 is a challenging data migration scenario. A company is setting up a disaster recovery site in AWS for their on-premises infrastructure. They have 10 TBs of data that needs to be transferred within 72 hours. They only have 1 GBP's internet connection, and the data needs to be transferred securely.
They need to move a large amount of data quickly and securely, but their internet connection is limited. This is where an offline data transfer method can really help.
Right, we need to bypass that internet bottleneck.
Exactly. Given the size of the data and the need for secure transport, the best solution is AWS Snowball. It's a service that uses secure appliances to move large amounts of data to and from AWS. The company can request a Snowball device, transfer their data to it, and then ship it to AWS. This offline transfer method is much faster than using the internet, especially with a limited connection, and it ensures security since the device is tamper-resistant and uses encryption during transit.
It's like having a dedicated high-speed courier service for your data, ensuring it arrives at its destination quickly and safely. Question 468 is about secure file sharing and collaboration. A solutions architect needs to replace an on-premises solution that allowed employees and partners to securely exchange files. They need a solution that's easily accessible from anywhere, both inside and outside the company.
They need a managed file transfer service that's secure and easy to use from different locations.
Right. Secure collaboration is key.
Exactly. The solution is to use AWS Transfer for SFTP to move files into and out of Amazon S3. It's a fully managed service that makes setting up secure file transfers using the SFTP protocol really easy. Employees and partners can connect using their existing SFTP clients, and the service uses IAM for authentication and authorization. This allows them to control access at a granular level, ensuring only authorized people can exchange sensitive information.
It's like having a virtual file room with multiple secure entry points, so authorized people can access and share files from anywhere in the world. Okay, question 469 is about securing the root user in a new AWS account. A company just set up an account and is concerned about security.
Securing the root user is absolutely essential. It's the most powerful entity in an AWS account.
Right, it has access to everything.
Exactly. They need to take steps to protect it from unauthorized access. First, they should create an IAM user for their daily administrative tasks and give that user the necessary permissions. That way, they don't have to use the root user for everyday tasks, minimizing risks.
Okay, so create a separate user for regular administrative work. What else should they do?
They should enable multi-factor authentication, MFA, on the root user. This adds another layer of security by requiring a second form of authentication, like a code from an app along with the password. This makes it much harder for someone to get into the account, even if they figure out the password.
It's like having a double lock on the door to your most valuable treasure chest. Question 470 is about designing a resilient storage architecture for a new media application using S3. The architect needs to make sure those media files are protected if an availability zone goes down, meaning the application can keep working. They also want to minimize costs and recognize that the access patterns for those media files can be unpredictable.
They need a storage solution that's resilient, highly available, and cost-effective, even with unpredictable workloads.
Right. Reliable and affordable, no matter the demand.
Exactly. The ideal solution here is S3 intelligent tiering. Intelligent tiering automatically moves objects between storage tiers based on access patterns. Frequently accessed files are stored in that fast, high-performance tier, while less frequently used files are moved to a lower-cost tier. This dynamic approach keeps storage costs down without compromising availability or durability. And since intelligent tiering works across multiple availability zones, even if one AZ goes down, the data is still accessible.
It's like a self-organizing media library that keeps the most popular content readily available while storing those less watched items in a more cost-effective way. Question 471 is about multiple EC2 instances needing to access shared storage at the same time. A company is running multiple Linux EC2 instances in a VPC, and their applications, which use a hierarchical directory structure, need to be able to read and write to shared storage concurrently. They're looking for a managed solution so they don't have to manage the infrastructure themselves.
Sounds like they need a network file system that allows concurrent access from multiple EC2 instances.
Right. Shared storage that's easy to manage.
Exactly. The best solution is to create an Amazon Elastic File System, EFS, and mount it on each of those EC2 instances. Amazon EFS is a fully managed elastic NFS file system that can handle concurrent access from multiple instances. It scales automatically as needed, ensuring they have enough storage, and it offers high availability and durability through data replication across multiple AZs.
It's like having a central library that all the researchers can access at the same time, allowing them to work together seamlessly. Good question 472 is about efficiently gathering data from multiple locations around the world. The company collects a lot of weather data from cities across different continents. Each site has a fast internet connection. They need to aggregate all this data into a single AWS region for their weather forecasting applications, and they need to do it quickly to keep their forecasts up to date.
This is a classic big data challenge, moving large amounts of data efficiently.
Right. We need to get that data from those different locations to their central AWS region as fast as possible.
Exactly. To speed up the data transfer from those global sites, they should enable Amazon S3 transfer acceleration on the destination bucket and use multi-part uploads to directly upload the data to that bucket.
Okay, so S3 transfer acceleration and multi-part uploads. How do those work together to make things faster?
S3 transfer acceleration uses Amazon CloudFront's global edge network to optimize transfer speeds. It's like creating a network of high-speed data pipelines that move that data from those remote sites to their S3 bucket. Multi-part uploads allow them to break those large files into smaller parts and upload them at the same time, further speeding up the transfer process.
It's a powerful combo that ensures those weather data streams flow smoothly and efficiently into their forecasting engine. Question 473 is about cost management and financial analysis in AWS. A company with multiple AWS accounts for different departments needs to monitor its AWS costs. They want to query those costs and usage reports from all those accounts in their AWS organization and do a detailed analysis of the bill each month. The solution should be able to handle lots of data without getting too expensive.
They need a centralized and efficient way to track and analyze costs across their entire organization.
Right. Keep a close eye on those cloud finances.
Exactly. They should combine AWS cost and usage reports, Amazon S3, and Amazon Redshift for this. They need to enable those cost and usage reports for all the accounts in their organization, sending them to an S3 bucket that gives them one place for all their cost data. Then they can use Amazon Redshift, which is a data warehouse service, to query and analyze those reports stored in S3. Redshift is built for high-performance data analysis, so they can do those complex queries and create insightful reports.
It's like having a team of expert accountants constantly tracking expenses and generating detailed reports, ensuring those cloud finances are in order. Okay, question 474 presents a common challenge: database scalability. A user has a MySQL database accessed by an increasing number of clients who need fast response times. The problem is that increasing demand is pushing the database beyond what the hardware can handle. The user is thinking of moving to AWS and is open to changing database systems to find a solution that can handle this growing workload with unlimited scalability.
This is where the power of a fully managed NoSQL database can be a game changer.
Right. We need something that can handle massive amounts of data and traffic.
Exactly. They should look into Amazon DynamoDB. It's a fully managed NoSQL database service designed for low latency and high scalability. It can handle huge amounts of throughput and storage capacity, making it perfect for applications with rapidly growing data demands.
DynamoDB is like having a database that can grow infinitely, adapting to even the most demanding workloads. All right, on to question 475, which deals with data migration and limited network bandwidth. A company needs to move 20 TB of data from its data center to AWS within 30 days. Their network bandwidth is limited, and they can't exceed 70% utilization. They need a solution that can move that data quickly and securely without affecting their day-to-day operations.
They need a way to move that data offline to avoid saturating their network connection.
Right. Keep those operations running smoothly.
Exactly. The best approach here is to use AWS Snowball. They can request a Snowball device, transfer their data to it, and then ship it to AWS. This offline data transfer method avoids putting too much strain on their network, ensuring those ongoing operations aren't disrupted. Plus, it guarantees that the data migration is completed within that time frame.
AWS Snowball is like having a dedicated data highway that bypasses all those internet traffic jams, enabling you to move large amounts of data quickly and securely. Question 476 is about limiting access to S3 buckets using gateway endpoints. A company has a rule. An S3 gateway endpoint can only allow traffic to specific, trusted S3 buckets. They want to make absolutely sure that no one can use that endpoint to get into any other S3 buckets, even if they have permission. What should the solutions architect recommend to enforce this strict security policy?
This is where resource-based policies are incredibly useful.
Okay, so we're talking about very specific access control.
Right. They should create an S3 endpoint policy for each of the company's S3 gateway endpoints. Those endpoint policies are like rules for those endpoints, controlling access. The solutions architect should create a policy for each endpoint, specifically listing the names of those trusted buckets, those ARNs. This ensures that only traffic going to those buckets is allowed through, even if someone has broader S3 permissions.
It's like having a strict security checkpoint at each gateway endpoint, carefully verifying each request to ensure it's allowed. All right, moving on to question 477. We're talking about encryption, both for data at rest and data in transit. A company stores log data in various S3 buckets and needs to make sure that data is encrypted both while it's sitting in S3 and while it's moving over the network.
They need end-to-end encryption to protect that data at every stage.
Right. Full protection from unauthorized access.
Exactly. To do this, they should use server-side encryption to encrypt the data as it's being uploaded to those S3 buckets. S3 has several options for this, including using S3 managed keys, keys managed by AWS KMS, or even customer-provided keys. By choosing one of these options, the data is encrypted as it's written to S3, ensuring encryption at rest. And then, enabling HTTPS for all S3 OPI calls makes sure the data is also encrypted as it travels over the network.
It's like having a two-person security team for that data, protecting it both while it's stored and while it's on the move. Okay, question 478 is about secure collaboration with an external vendor. A company wants to give an external vendor write access to its SQS queues. The vendor has their own AWS account. The company wants to follow least privilege principles, giving the vendor only the permissions needed to write to those specific queues.
They need to grant access across accounts while ensuring the vendor only has the permissions necessary.
Right. Controlled access without oversharing.
Exactly. The solution is to create a cross-account IAM role in the company's account. This role should have a policy that allows writing to those specific SQS queues. In the trust policy of that role, they should specify the vendor's AWS account ID. This lets the vendor assume that role from their own account and get the permissions to write to the queues without needing an IAM user in the company's account.
It's like building a secure bridge between the two accounts, allowing controlled access to specific resources without compromising the security of either account. Question 479 is about managing high-volume data ingestion and storage. A company has thousands of edge devices that generate a massive amount of data each day. They need a reliable solution to ingest and store these alerts for analysis later. Keeping costs low and operations efficient is crucial. They also need to keep the most recent data readily available while archiving older data to a less expensive storage tier.
They need a system that can handle a high volume of incoming data, manage different data retention periods, and optimize costs.
Right. Efficient, affordable, and organized.
Exactly. They can achieve this by using Amazon Kinesis Data Firehose to ingest those alerts. They can then configure the Kinesis Data Firehose stream to deliver those alerts to an S3 bucket and set up a lifecycle configuration to transition that data to S3 Glacier after 14 days. This way, the most recent data is always accessible in S3 for analysis, while older data is archived to Glacier for long-term storage at a lower cost.
It's a great way to manage that constant influx of data, store it securely, and archive those older alerts without spending a fortune. All right, let's move on to question 480, which is about real-time processing at the edge with an unreliable internet connection. A factory in a remote location with spotty internet needs to process machine and sensor data locally to control the movement of products. They need predictable, low-latency computing for this system to work correctly.
This is where edge computing can help overcome those connectivity challenges.
Right, bringing the processing power closer to the data source.
Exactly. To handle the unreliable connectivity and the need for low latency, they should use Amazon CloudFront Lambda at edge functions. Lambda at edge allows you to run Lambda functions at CloudFront's edge locations, which are spread out globally and closer to users and devices. By deploying a Lambda at edge function to process that machine and sensor data, they can do those calculations locally even when the internet connection isn't stable. This allows that control system to respond quickly to changes without depending on a consistent internet connection.
It's like having a team of highly skilled technicians stationed right there on the factory floor, ready to respond instantly, no matter what's happening with the internet connection. Question 481 is about data replication and quick access to those backup files. A company wants to replicate its data to AWS for disaster recovery. Their current system uses scripts to copy data to an NFS share, and their admins need fast access to those backup files to handle any issues or quickly restore data. They want a solution that replicates their data to AWS while maintaining that quick access their admins need.
Sounds like they need a solution that bridges their on-premises environment with AWS, providing both backup and accessibility.
Right, data protection and easy access when they need it.
Exactly. To do this, they should update their scripts to copy that data to an AWS storage gateway for Files Gateway virtual appliance instead of that on-premises NFS share. Storage Gateway for Files provides a smooth way to connect on-premises storage with AWS. It lets them create backups in S3 while still having quick access to those files through a local cache. This means their admins can access those backups quickly, even if the main data center is offline.
It's like having a magic mirror that synchronizes their on-premises storage with AWS, providing both protection and quick access. Question 482 is about implementing location-based access controls for a web application. A company's web application is running on EC2 instances behind an application load balancer. A new policy says the application can only be accessible from a specific country. They need a way to restrict access by location to comply with this policy.
They need a way to control access based on where the user is coming from.
Right, like a virtual border control for their application.
Exactly. The best solution here is to configure AWS WAF on that application load balancer. WAF lets you create rules that manage access to web applications. They can create a rule that allows traffic only from the countries specified in the policy, blocking access from everywhere else. WAF is a flexible and powerful way to implement those security policies and protect those applications from unwanted traffic.
AWS WAF is like having a digital border patrol for their web application, carefully screening visitors to ensure they're allowed entry. Question 483 is about web application security and dealing with cross-site scripting attacks. A web application deployed on AWS with a web tier and a database tier is susceptible to XSS attacks. They need to put security measures in place to prevent these attacks.
They need to add layers of security to protect the application and data from those XSS attacks.
Right. Strengthen those defenses.
Exactly. They should start by putting the web tier behind an application load balancer. This creates a barrier between the internet and those web servers, making it harder for attackers to target them directly. Then, they should enable AWS Wave on the ALB and configure rules to detect and block those common XSS attack patterns. Wave acts like a shield, analyzing incoming traffic and blocking requests that look suspicious.
It's a powerful combination that provides both protection and proactive threat prevention. Question 484 focuses on network configuration and troubleshooting. There's a web server running on an EC2 instance in a public subnet with an elastic IP. The default security group is assigned, and the network ACL has been modified to block all traffic. They want to make that web server accessible on port 443 for HTTPS from anywhere on the internet.
They need to adjust both the security group and the network ACL to make that happen while maintaining a secure environment.
Right. Allow the right traffic in while keeping everything else out.
Exactly. First, they should create a new security group for the web server and allow inbound traffic on port 443 from 0.0.0.00, which means anywhere on the internet. Then, they need to update the network ACL to allow inbound traffic on port 443 and outbound traffic on ephemeral ports to enable responses to those incoming requests. It's important to remember that network ACLs work at the subnet level, so these changes will affect all instances in that subnet.
It's like setting up the right doors and windows in your house, making sure you can get in and out easily while keeping unwanted visitors out. And that, my friends, brings us to the end of our deep dive into these practice questions. We've covered a lot of ground today, from storage and databases to networking, security, and even some serverless concepts.
It's been quite a journey through the world of AWS solutions architecture.
We hope you've gained valuable insights and strategies that will help you on your path to becoming an AWS Certified Solutions Architect Associate.
Remember, practice is key to mastering these concepts.
Exactly. Keep exploring, keep learning, and keep building on AWS. Until next time, happy clouding.